Hello. Hello, hi everyone, and welcome to the post contest analysis of Weekly Coding Contest 123. My name is Karan Mashru, and today we'll be discussing all the four questions which were asked in Weekly Coding Contest 123. Okay, first of all, please let me know if I'm properly audible. हेलो, एम आई प्रॉपर्ली ऑडिबल? ओके ओके. सो आई होप कि आपका ये कंटेस्ट अच्छा गया होगा. सो लेट्स स्टार्ट द डिस्कशन. आई जस्ट सेट अप माय स्क्रीन एंड शेयर इट. एंड sorry for this bad hairstyle, but it's Sunday, so I hope you people understand. Weekly coding contest 123. Okay, so let me close down, let me share my screen. So I hope my screen is visible. Only two questions are done. Okay, no problem. Don't worry. We'll discuss the other two questions. Okay. Make sure you understand the other two questions properly from the video editorials. If you have doubt, then definitely please let me know. Okay. Okay, screen is visible. So first of all, let us start with the first question, that is squares. Okay. So what does this question say? Initially given a square of side 2 ki power n, you can perform the following operations. Pick any square if the side of the square is 2 ki power m, where m is greater than 0. Then you can divide this square into four smaller squares of side 2 ki power m minus 1 and replace the bigger square with these four squares. Okay. Okay. Then what you can do is you can perform as many operations as you want. Your task is to find minimum number of operations needed to make at least x boxes. If it is not possible to make x boxes, then return minus 1. Okay. So basically in this question what they are trying to say is, in the input you are given n. Okay. So you need to consider a square of size of side 2 ki power n. Okay. So let's say your n is equals to, let's say, 2. So you need to consider a square whose side length is 2 ki power 2, which is nothing but 4. Okay. So if you consider a square of side length 2 ki power 2, then it would be like this, something like this. Right. So initially this is whole one square. Okay, I have just divided into 4 rows and 4 columns to show you 1 unit each. Okay, so the total side length is 4, okay, of this square, and initially it is only one square. Now in any operation you can do, what you can do is you can select a square of size 2 ki power m, where m is greater than 0. So you can select a square of size 2 ki power 1, of 2 ki power 2, or 2 ki power 3, and so on, whichever is possible, of side length 2 ki power m, and divide this square into four squares of sides 2 ki power m minus 1 and replace this bigger square with this four squares of side length 2 ki power m minus 1. Okay. So for example, you select this square with side length 2 ki power 1. Okay. So this is a square of side length 2 ki power 1, right? You selected this square, which is basically this much. So you selected this square and divided into four different squares. So your m is equals to 1. Okay. So you selected this square, which is of side length 2. So you divide this square into four different squares of this size, which is nothing but 1. So you get four different squares. Okay. And you replace this bigger square with this four different squares. Okay. So you replace this bigger square with four different squares. Okay. So this becomes your one square, this becomes your another square, this becomes your third square, and this becomes your fourth square. Okay. So in this way you basically need to make total 2 ki power total you need x squares, at least x squares, not x squares but at least x squares, right? Now tell me, in every step how many squares are increasing? So basically you select one square of length 2 ki power m and convert it into 4 squares of length 2 ki power m of side length 2 ki power m. So after every operation the number of squares increasing is 3, right? So at every step your x, the requirement, decreases by 3, right? So I can say that how many minimum steps I would require to get at least x squares. That I can get by, first of all, suppose x is 8, okay, I want 8 different squares. Then first of all I will do x minus minus, that is my requirement will be 7. Why? Because initially I have one bigger square, right? Initially I have one square. Now at every step 3 squares will increase irrespective of what m value is, right? Because whatever the m value will be, I'll replace one square of length 2 ki power m with 4 squares of length 2 ki power m minus 1. So my number of squares will increase by 3 irrespective of the length of m, right? So initially I have one square and now at every step 3 squares will increase. So after first step I'll need 4 squares, after second step I'll need one square, and after third step I will have two more squares, okay? So basically initially I will have one square, the bigger square. Then after one operations I will have 4 square. Then after another operations I will have how many squares? 7 squares, but I want 8. And after one more step I will have 10 squares, which is more than 8. So total I will require 3 steps. So basically first of all what we will do, we will do x minus minus, because we want the number of squares to be x. Initially we have one square and at every step 3 square increases, okay? So first of all I'll do x minus minus because initially I have one square. Then I will say my answer is equals to x divided by 3, because at every step I get 3 more squares, right? But x may not be a multiple of 3. Like if x, after doing x minus minus, x is 7, okay? So after one step 4 more will be required, after second step 1 more will be required, right? So I can say if x modulo 3 is not equals to 0, then answer plus plus. See, basically after I will consider, after every step 3 more squares are increasing. Finally I want at least x squares. Initially I have one square, so I did x minus minus. Now at every step I need 3 more, at every step 3 squares are increasing in the total number of squares, right? So if I have 6 squares required, I will need 2 steps. If I have 7 square required, I will need 2 steps. If I sorry, 3 steps, right? If I have 8 squares more required, then I will also need to do 3 steps. If I have 9 more squares required, then also I need 3 steps. But if I have 10 more square required, I need 4 more steps. Okay, so that is basically what we are doing. Okay. Also, when will we return minus 1? When we cannot make x number of squares. Okay, so what will be the case? So what is the smallest square possible? That is, each square will be of 1 unit, right? So if the length of the side of the initial square is 2 ki power n, then total number of squares maximum possible is 2 ki power n into 2 ki power n. So if x is greater than 2 ki power n into 2 ki power n, then I will return minus 1. Is this much clear? Can you explain this? 3 steps are increasing 1. Okay. So basically, see what's happening is, see, whenever I select a square, okay, don't think about its length. Suppose I selected a square whose length is 2 ki power m, okay? So now I divided into 4 squares of length 2 ki power m minus 1, okay? And I will replace this bigger square with this 4 different squares, 1, 2, 3, and 4. So initially there was this one big square. Suppose my number of squares at a particular point of time is sq, then it will become sq minus 1 because this big square is now destroyed and 4 new squares are added. So total number of squares which are incremented are 3. Is this clear, Monty? So any doubt, please let me know. Now let me show you the code for it. Okay. Okay, so this is the code. So okay, got it. So first of all, side length is how much? 2 ki power n. So it is 1 left shifted by n times total number of squares maximum possible is side into side, right? Because if the length of the square is 2 ki power n, maximum total number of squares is 2 ki power n into 2 ki power n. So if x is greater than total, then return -1. Okay. Otherwise, first do x minus minus, because initially there is one square. Then at every step, 3 number of squares increases. So my answer would be x by 3. But x may not be a perfect multiple of 3. If it is not a perfect multiple of 3, then one more step will be required at the end. So answer plus plus. And finally, I'll return answer. Okay. So is this clear? Shall we move on to the next question? Why did you choose long data type? So basically, I was not thinking about making it too much efficient at this step. Just my target was that I do not get overflow and underflow issues. So usually what I do is I take long type. Okay. So it's not the most efficient in terms of memory, but I usually take it while doing competitive programming or participating in online contest. Can you explain that total part? Okay. See, here my n is equals to 2. Okay, suppose my n is equals to 2. So the length of the square, side length is 2 ki power 2. That is nothing but 4. So this side length of the square, initial square is 4. So the height will be 4 and the width will be 4 because it is a square. Sorry. So the maximum number of squares possible is how much? See, you keep dividing the squares into 4 parts. Ultimately, you can only divide a square of length 2 ki power m where m is greater than 0. So the smallest square which you can divide is 2 ki power 1, which is of side length 2. So suppose you have a square of side length 2, you divide it into 4 parts, so you get 4 squares of side length 1. Now you cannot divide them further. Okay. So if the side length is 4, then the maximum number of squares which you can get is all the squares are of length 1. And if all the squares are of length 1, then the total number of squares would be 16. So that is how I got the total. Okay. Is that clear? Pawan, is that clear? Okay. Tushar is asking why x minus minus. Please explain with example and dry run. Okay. So understand one thing. See, suppose my n is equals to 2. Okay. So this will be my square. Okay. This is my initial square of length 4. Okay. Suppose my x is 8, that I want 8 squares. Okay. So what I'll do is, first of all, I'll divide this bigger into 4 smaller squares with length 2. Okay. So initially I had number of squares equal to how much? 1. Now I have number of squares equal to how much? 4. But I need 8. So let me divide this one into 4. Okay. So these all will be of length 1. So now the number of squares is how much? 7. This is one square, this is second square, this is third square, this is fourth square, this is fifth, this is sixth, and this is seventh. Now let me divide this also into 4 parts. So the number of squares will be how much? 10. So this is 7th square. Let me take, okay. So this is 1, 2, 3, 4. This is 5, 6, 7, 8. This is 9 and this is 10th square. And my work is done. So how many steps I required? 1, 2 and 3. My answer is 3. Okay. Is this much clear? Now understand one thing. At every step, I am getting 3 more squares. Okay, from 1 we went to 4, from 4 we went to 7, and from 7 we went to 10. Right? What we are doing is, so suppose let's say, uh, let's say I want to buy, let's say 14 fruits. Okay, and in one pack I will get 3 fruits. Okay, exactly 3 fruits, and I want at least 14 fruits. So what I'll say, okay, give me 3 fruits, remaining is 11. Give me 3 fruits, remaining is 8. Give me 3 fruits, remaining is 5. Give me 3 more fruits, remaining is 2. Give me 3 more fruits, remaining is 0. Total I'll get 15 fruits. But I need to buy 5 packs, right? Similarly here, so here we are decreasing the count, right? Basically first required was 14, then required was 11, then required was 8. Why? Because at every step I am getting 3 more fruits. Similarly, if I want total number of squares to be 8, initially I have one square of side 4 by 4. Initially I have that one square. So my I'll do x minus minus for this initial square. So now I need 7 more squares. So now from 7, when I'll perform this step, I'll get 4 squares. So the remaining is how much? In one step, I'll get 3 more squares. So remaining is 4. For that initial 1 square, I am doing x minus minus. Then at every step, 3 more squares will be added. Now is it clear? Or you can think of it in reverse direction. Okay. Yeah, you can take seal as well. Definitely, you can think of it in reverse direction. Let y be the number of cells at present, so you will initialize it with 1, and at every step you will increase it by 3, right, until it becomes greater than equal to x. So this initial one, if we take initial one, if we are increasing y, but we are trying to decrease x, so we are taking x minus minus. Okay, is that clear? But I would not suggest taking ceiling. Okay, at the last step you can take ceiling of x by 3 modulo, but do not do ceiling of directly ceiling of x by 3. You need to do minus minus, because if the required number of squares is 10, then 10 by 3 ceiling would be equal to 4. But you will not require 4 steps, you will require only 3 steps, because initially you have 1 square, then you will get 4 squares, then you will get 7 squares, and then you will get 10 squares. So basically you do x minus minus, and then your answer will be equal to x by 3 and ceiling of that. Now is it clear? Okay, so let's move on to the next question. There are 30 people in the stream watching now, right? And we have only 18 likes. Please like kar do sabhi log. If you are liking this editorial, we will be discussing 3 more questions. Okay, and I know fourth one was quite good. Okay, we will be discussing that also in detail. Okay, let's move on to the next question. ऑल्सो अगर आपको ये एडिटोरियल्स अच्छे लगते हैं, देन यू मे टेक अ स्क्रीनशॉट एंड शेयर ऑन लिंक्डइन एंड टैग मी, टैग geeks for geeks, टैग संदीप जैन सर, एंड I'll make sure that you get reactions from the official account of geeks for geeks. Okay, so this is the second question. Find boats on geekland stir. Okay, so let's begin. There are a lot of boats on one of the popular social media platform geeksterland. Okay, now since Geeklandster, okay, not Geeksterland, it is Geeklandster, has been acquired by the richest man of Geekland, he wants to remove every bot from his platform. Okay, so basically, this is the second question. There is a social media platform and there are a lot of bots on it. Okay, bots means machine accounts. Okay, and it has been purchased by someone and he wants to remove all the bots from it. Geek used his magical powers and determined that the count of the distinct characters at even positions of username is a prime number for every bot. Okay, so basically what they are trying to say in this statement is, if there is a bot account, there will be a username associated with it, there will be a username associated with all the accounts. Okay, but for the accounts which are bot, there is a pattern. What is the pattern? In their username, if we count the number of distinct characters at even position, that is 0th, 2nd, 4th, 6th, and so on, and if the number of distinct characters at this position is a prime number, then this is a bot account. Okay, so basically let's say A, B, C, D. So this and this are two different places. Uh, sorry. So this is zero. Suppose this is a username of one account. Okay, this is zeroth index, this is one index, this is second index, this is third index. Zero and second index are even indexes. They have A and C. So there are two distinct characters. Suppose there is A, B, C, D, E, F, G. Okay, this is the username. Sorry, there will not be commas, but let's say A, B, C, D, E, F, G. Okay, so this is zero index 1, 2, 3, 4, 5, and 6. So this is even index, this is even index, this is even index, this is even index. It is A, C, E, G. So there are four distinct characters. Here there are two distinct characters at even position. 2 is a prime number. So this username ABCD is a bots account. Here the total distinct characters at even positions is 4, which is not a prime number. So this username is not a bots account. Similarly, if it is A, B, C, D, E, F, A. So if we look at even positions, it is 0, 2, 4, and 6. The characters at these positions is A, C, E, A. Total number of distinct character is 3. Total characters are 4 at even positions, but distinct characters are 3. 3 is a prime number, and hence this username is a bots account. Did you understood the question? You have been given an array of strings usernames, and for each of them tell if the user is a bot or not by returning an array of integers where 0 corresponds to human and 1 corresponds to bot. Okay, so basically suppose my number of users is 6, then I will be given 6 usernames. Okay, and I need to return an array of integers which has 0 and 1, where 0 denotes what? 0 denotes to human. It means that these account are human accounts and these accounts are bot accounts. And how will we identify bots? We will count the number of distinct characters for each username at even positions. If that count is a prime number, then that account is a bot, otherwise it is not. Is this much clear? Please, can you explain it once more? Okay, so basically, see, understand one thing. In the input, we are given an array of strings. Let's say the size of the array is n. Okay, so this basically represents, it is an array of strings. Okay, so we will be given n strings. These strings will represent the username of n accounts on a social media platform. Now, with the help of username, we need to return whether it is a bot account or a human account. And how will we return? Suppose n is equals to 6. So we will return an array of size 6 consisting of zeros and ones, where 0 will represent it's a human account and 1 will represent it is a bot account. Now, how will we know if the account is a bot account? If the number of distinct characters at even position is a prime number. So basically, let's say one username is A, B, C, D, E, F, G. Another username is A, B, C, D, E, F, A. So if I write the positions, then this is 0, 1, 2, 3, 4, 5, and 6. This is 0, 1, 2, 3, 4, 5, and 6. These are the even positions. I want to count the distinct characters at even positions. So if I write the characters at even positions, it is A, C, E, G. Here the characters at even positions is A, C, E, A. So the distinct characters here in even positions is A, C, E, G. Here the distinct characters at even positions is A, C, and E. The total number of distinct characters at even positions here is 4. Here the total number of distinct characters at even position is 3. 3 is a prime number, hence this is a bots account. 4 is not a prime number, hence this is not a bots account. In this way, we will calculate whether account is a bots account or not. Is now clear, status world? So let's move on to the implementation part. Okay. Okay, no problem. So basically what I've done is I've taken one vector answer in which I will store 0 and 1 based upon whether it is a human account or bot account. Then I've taken some variables and I've taken one counter array of size 26 So C of 0 will represent count of A, C of 1 will represent count of B, C of 2 will represent count of C, C of 25 will represent count of Z in a username. So I have traversed through the array of usernames I equals to 0 to n. First of all, I have taken the length of the ith username. So m is equal to usernames of I dot size. Then I have initialized the count at count of all A to Z as 0 initially, and I have taken P as 0 initially. P is the count of distinct characters in the ith username. Okay. Now I will be traversing from j equals to 0 to m, where m is the length of the username. So I will be traversing through the username, and I will do j plus 2 because I only want the count of distinct characters at even positions. Then I will say count of username ij minus 97 plus plus. So usernames I means ith username and j means jth character of the ith username. Suppose it is A. So A's ASCII value is 97. So 97 minus 97 will give me index 0. So C of that will be plus plus. So count of A, B, C, any character will increase. If the count is 1, it means this character is encountered for the first time. It means it is a unique character. It was not encountered before. So I will increment the count of unique characters. So I will say P plus plus. Then I will call a function prime of P. If it returns true, if the number is prime, I will push back 1 in the answer because this ith username is a bot account. Else I will push 0. If we look at the prime function, so it basically says if P is 1, return false because 1 is not a prime number. Otherwise, for 2 to square root of P, if there is any I which divides P, if there is a factor of P, then it is not a prime number. I'll return false. And if this does not occur anytime, finally I will return true and saying that it is a prime number. Now, is everything clear? Hello, hi Kriti. So we have solved this successfully. Can you provide the link of the solution in C++? Okay, sure. We can solve it using unordered set also. Okay, so you can take unordered set of counting, okay, of characters. But unordered set worst case may increase. Here it will not increase because there are only 26 characters, right? Let me know if you have any doubt in this, okay? So let me just copy down the solution. Let me just paste it. Let me generate it. Code for second question. Any doubts in this question? I learn all the core Java concepts and a little bit of DSA, but unable to solve coding challenges on HackerRank, etc. So what I would suggest is both first problems are one-liners in Python. Okay. So what I would suggest, Kriti, is that I would suggest that if you have learned the concepts of languages, then I would still suggest you, if you are a beginner, to solve questions topic wise. So starting with basic implementation questions, then arrays, then linked list, then stack, bit manipulation, and so on. Try and learn all the topics one after the another. Once you have covered a good amount of topics, then go come to solve coding challenges. Okay, because in coding challenges, question may come from any topic. So in the initial time, do not focus much on participating in contest. Focus more on covering more areas and learning more. Once you have covered a good enough of areas, then focus on participating in competitions. Okay. So I would suggest you that. And if any of your topic is weak, then focus on that first. Okay. यस ओके ओके हैश सेट मैप क्यों लगा रहे काउंट वेरिएबल से स्ट्रिंग के लिए काउंट करते जाने सौरभ कुमार ओके ओके कृति constraints are too less like 10 की power 4 okay yes there can be multiple ways of solving this problem okay any doubt in this or we'll move on to the next question or let me just clear it at present. Okay. Okay, shall we go on to the next question? Okay, so next question is or sum. Given two arrays A and B of size n and m, you have to find the sum of bitwise or of all the pairs A into B. That is pairing every element of A with every element of B. There will be exactly n cross m pairs. As the answer can be large, you have to find the answer modulo 10 ki power 9 plus 7. Okay. Okay. So basically, what they are saying is that, let's move on to the third question. They are saying that we have been given an array A which has n elements, and we have another array B which has m elements. So you need to make pair between each and every element of A and each and every element of B. Okay. And so basically, for all I between 0 and less than n, and for all j between 0 and m, I need to calculate A of I or B of j. So I need to do bitwise or between them, and I need to add it to my answer. This is the question. The brute force approach to be used two for loops and add all the bitwise or of A of I or B of j to the answer. But in that case, the time complexity would be big O of n cross m, and it will give us time limit exceeded. So we need to think of something more efficient, right? Is the question clear? Second question's code link seems weird. Okay, is it opening? Just open it once if you are able to go to the code properly. Oh, second question's solution code link. एक्चुअली वो कोड कॉपी ही नहीं हुआ था, और पहले से क्लिपबोर्ड पे फोर्थ क्वेश्चन का कोड था कॉपीड, सो इसलिए आई थिंक वो ऐसे हो गया. Is it okay now? Okay, no problem. So basically, this would be the brute force method to basically go through all the pairs of array A and array B, take bitwise or between them, and add it to our answer, but it will give us time limit exceeded. So now how can we solve it efficiently? See, whenever you get a bitwise question and if you want to solve it efficiently, in most of the cases, what you need to do is, I'm double quoting it, think solving bit by bit. What you need to do, think solving the problem bit by bit. Okay, so what would be the contribution of this bit to my answer, what will be the contribution of this bit to my answer, what will be the contribution of this bit to my answer, and so on. Okay, so in this question, what we can do is, let's say, what is the range of numbers? I think it goes up to 2 ki power 30. Okay, so it is less than 2 ki power 30. Okay, so the bit numbers will be from 0, 1, 2, 3 up till 29, right? This bit will have value 2 ki power 0, next will have 2 ki power 1, next will have 2 ki power 2, up to the last bit will have value 2 ki power 9. So can I think, see, basically what is my answer? My answer is nothing but summation over all the pairs AI bitwise odd with B of j for all I and j possible, right? The summation of this, that is my answer. So in my answer, what I can think of is, how much is the contribution of 0th bit, how much is the contribution of first bit, how much is the contribution of second bit, and up to how much is the contribution of 29th bit. Is this okay? I did by calculating contribution of bit between, yes, definitely. Right. So now, so now what would be the contribution of the ith bit in general? Okay, so there can be multiple ways of calculating it. Okay, suppose you have an array c1 of I, which basically tells you just a second, just 10-20 seconds break. Okay. Okay, so let's continue. I hope I am properly audible. Okay. So what will be the contribution of the ith bit to my answer? So can I say number of pairs of AK1 and BK2 in which, after taking OR between this AK1th element and BK2th element, my ith bit is set. Okay, my ith bit is set. So number of pairs in which my ith bit is set after taking bitwise OR multiplied by 2 ki power I, because this many would be the number of pairs in which ith bit would be set, and the value of the ith bit is 2 ki power I. So this will contribute this much to my answer. So if I do this for all the I from 0 to 29, I have solved my problem. Is it clear? Now I want to find the number of pairs of the first array and the second array, and I want to find the number of pairs in which one element is from the first array and another element is from the second array, such that the bitwise OR between them has ith bit set. Okay. So now how many pairs would be such kind of that? See, understand, if in a pair AK1 and AK2, if I want the ith bit to be set, there are four cases. Okay, that ith bit is not set in both, or set in sorry, this is BK2. Okay, or set in B and not set in A, or set in A and not set in B, or set in both. So when I'll do bitwise OR, it will be 1 in these three cases and it will be 0 in the first case. Is it clear? So there are different ways of calculating it. Okay, suppose C1 of I represents the number of elements of array A in which ith bit is set. and C2 of I represents number of elements of array B in which ith element is set. Okay, so what will be the total number of pairs A comma B such that in that ith bit will be set? So these three would be the cases. So I can say C1 of I multiplied by C2 of I, that is number of elements in array A in which ith bit is set multiplied by number of elements in array B in which ith bit is set. Suppose there are 5 elements in array in which ith bit is set, and suppose there are 6 elements in array B in which ith bit is set, then 5 into 6, these 30 pairs will have ith bit set. They form this case, plus C1 of I multiplied by M minus C2 of I, that is number of elements of array A in which ith bit is set multiplied by number of elements in array B in which ith bit is not set. So it will be this case, the bit is set in A but not set in B, plus C2 of I multiplied by n minus C1 of I, that is number of elements in array B in which ith bit is set multiplied by number of elements in array A in which ith bit is not set. It will consider this case. So these will be the total number of pairs multiplied by 2 ki power I will give me the total contribution of I in my answer. And if I do this for all the elements, my work is done. Is the concept clear? Okay, so let's move on to its implementation. Right, so what I have done is I have taken answer equals to 0, mod equals to 10 ki power 9 plus 7, C1 and C2 of size 30 because the maximum bit will be 29, and I have taken variables to iterate. Then I have done C1 of I equal to C2 of I equal to 0 for all the 30 elements. Then for all the elements of array A, I want to fill C1 of I. C1 of I is basically number of elements in array A in which ith bit is set. Okay, so J will run from 0 to 30, and C1 of J plus will be equal to A of I modulo 2. And at each step, I'll divide A by 2. Okay, so basically what I'm doing is, suppose my ith element is, let's say 12 or let's say 13. Okay, so what is 13? It is 1101, 8 and 4 12 and 1 13, and your remaining 26 would be zeros. Okay, so I would say I would it make a loop of size 30. So in the first step I will get 0th bit, right? This is 1101, right? It so I will say C of C1 of 0 plus is equals to A of I modulo 2. So if this bit is 1, my number will be odd, and A of I modulo 2 will give me 1. If this bit is 0, my number will be even, and this A of I modulo 2 will give me 0. So if it is 1, then that would be added to my answer. Okay, so this will be C1 of I. Okay, I will start from 0 to 29. Then after first step, I'll divide my number by 2. So it will become 110, and your remaining 27 bits will be 0. So basically the bit which was at first position came at 0th position. Okay, after dividing it by 2. So now I will say C1 of 1 plus is equals to A of J or A of I. This is the ith element modulo 2, right? Since this is 0, so the 1th bit is 0. Okay, so its contribution would be 0. Did you understood this? How it is calculating, how it is contributing to the ith bit? Anyone has any doubt? Okay, so in that way, for all the elements of array A, I went over all the 30 bits, and I added 1 if it was 1. Okay, and so I will get C1 of I, that is the total number of ith bits set in array A. Okay, similarly I did for array B. Okay, and then I went from I equals to 0 to 30, and my j is equals to 1, and every time I am multiplying it by 2. So j is basically 2 की power I. Okay, it is representing the bit value, and answer is equals to answer plus c1 of I into c2 of I plus c1 of I into m minus c2 of I plus c2 of I into n minus c1 of I multiplied by j. So these are the total number of pairs, and j is the bit value, and at every step I am taking modulo mod so I do not get overflow, and then finally I'll return answer. Okay, understood. Although I did a AND operation with 2 key power I. Okay, yeah, that will also work. So you can say if you are talking about ith bit and whether it is set in a or not, you can take a bitwise AND between 2 key power I and a. If that is greater than 0, then ith bit is set, you can increment the counter, otherwise you will not increment the counter. That will also work. Any doubts in this? This is something new, a of I by 2. Yes, so a of I divided by 2 is basically right shifting the number every step by one position. Okay, no doubts. Okay, so now we are going to move on to the fourth question, that is obsessed with minimization. Let me tell you, this is a very good question. It will take a lot of time. Okay, so lot of time in the sense that some topic I might need to make you explain multiple times. I will give my best, but I think you will understand it completely. So I request, there are 35 people. Okay, do not leave. Okay, everyone, you will understand this question completely. Okay, and if you have any doubt, you can ask me multiple times. Okay, but this is a very good question. In this you will learn a lot of things. Okay, and there are only 26 likes, so make sure you like this stream if you are liking my solutions. Okay, so let's begin with the final question. So what does this question say? There are n cities in Treeland numbered from 0 to n minus 1. M parcels are present on source I and are to be delivered at destination I. Okay, okay. So basically what they are saying is, there is a Treeland. Okay, in Treeland there are n cities and the number of cities are from 0 to n minus 1. We need to deliver m parcels. The ith parcel is to be delivered from source of I to destination of I. Okay, so basically we are given two arrays, source and destination of size m, where ith element of source I represents the source city of the ith parcel and destination of I represents the destination city of the ith parcel. Okay, okay. The structure of Treeland is given by array P and W of size n, where P of I is the direct ancestor of ith city and Wi is the cost of rod connecting Pi and I. Okay, so basically they are saying that the structure of this Treeland is given with the help of two arrays P and W, where P of I is the direct ancestor, direct parent node, if it looks like a tree. Okay, so basically these nodes, these cities will form a tree, is direct ancestor of ith node, and Wi is the cost of the path from ith node to P of ith node. Okay, the direct ancestor of it, this is the cost of this path. And P of 0 equals to minus 1 and W of 0 equals to 0, as 0th is the capital city. Okay, so they are saying that P of 0 equals to minus 1, there is no parent city of 0, and W of 0 is 0, because if there is no parent city of 0, how can there be a path from parent city to 0, and there cannot be its associated weight, so it is 0. So basically it will form a tree where 0 is the parent node. Okay, we will just see now with the help of an example. You can swap the cost of any two roads as many times as you want. Your task is to minimize the cost of parceling all the items. So basically what they are saying is we can swap the cost of any two roads as many times as I want. So can I say, if let's say I have 10 roads, there will be 10 costs associated with these 10 roads. So basically, not considering the zeroth, I am considering the 10 roads, okay? Not considering the 10. Okay, let me I explain you with the help of an example, okay? So that would be even better. So this is 0, 1, 2, 3, and 4, okay? So we have 0, 1, 2, 3, and 4, okay? Or let's take it like this only. Let's look at first example, okay? N equals to 5, m equals to 2, n equals to 5, m equals to 2. There are some comments. The extra problem can be used here. Why do we use 7 in int max define number of bit? Okay, sorry guys. Just a small request from Pawan. So, okay, Pawan. So I'll tell you. So just a second, guys. So basically, this was the equation: the total number of pairs in which the ith bit is set. So ith bit will be set if it is set in both the A, K, one element of array A and one element of B, or if it is set in any one of them. Okay. So C1, so C1 of I into M minus C2 of I represents number of elements in array A in which the ith bit is set, multiplied by number of elements in array B in which ith bit is not set. Because M is the total number of elements in array B, C2 of I is the number of elements in array B in which ith bit is set. So M minus C2 of I will be number of array elements in B in which ith bit is not set. But if they are paired with an element of array A in which ith bit is set, doing bitwise OR between them will give me ith bit set. So that's why I said C1 of I multiplied by M minus C2 of I. Is it clear now, Pawan? So what's the parent array? Minus 1, 0, 0, 1, 1. Okay. Parent array is minus 1, 0, 0, 1, 1. Okay. And what is the weight array? Okay. 0, 1, 2, 3, 4. Okay. Weight array is 0, 1, 2, 3, and 4. Okay. So basically, if we try to form up a tree from it, so this basically n is 5. So my node numbers will be from 0 to 4. Okay. And this is the parent array, which says that 0th parent is minus 1. So there is no parent of 0. 1's parent is 0. 2's parent is 0. 3's parent is 1. And 4th's parent is 1. So I can say 0 is the topmost node. Then 1's parent is 0, 2's parent is 0, 3's parent is 1, and 4th's parent is also 1. So this is the tree which I get. Then this is the cost of path between 0 and its parent, but there is no parent of 0, so it is 0 by default. This is the cost of the path between 1 and its parent. This is 1, this is the parent of 1, the cost of this path is 1. This is the cost of the path between node number 2 and its parent. This is node number 2, this is its parent, this is the cost of this path. This is the cost of the path between node number 3 and its parent. This is node number 3, this is node number 1, which is parent of 3. This is the cost of this path. This is the cost of the path between node number 4 and its parent. So this is node number 4 and its parent. So the cost of this path is 4. Now they have said that I can swap the cost of any two roads. Okay, so and any number of times. So basically, can I say, if there are, let's say, k number of roads and k number of costs associated with it, I can give any cost to any road. I can give this 2 to this road. I can give this 3 to this one. I can give this 1 to this 4. I can give this 4 to this one. Is this much clear? First, let me know. So if there are k roads and k cost values, I can give any road any cost, because I can swap any cost with any road any number of times. Is this clear? I think there is a small mistake in the exam as it says 5 in road cost. I Where is the road cost 5 in the graph? Okay, so here there is 5, but here they have given 4. Okay, if you look at this array, so here there is 4. Here they have written 5. Okay, so yes, there is a small mistake, I guess, between 1 and 3. Okay, no problem. We'll look at this. But is this much clear? Let me know, please. Please write clear or something. Then we'll move forward, because in this question I want to go step by step. Okay. Okay, it's clear. Okay. Now understand one thing. We were said that we need to deliver m parcels, and here source city and destination city will be given with the help of two arrays. So the source of I and destination of I will be the source city and destination city of the ith parcel to be delivered. Okay. Now understand one thing. Here you might get confused, but it is not mentioned. But basically, we need to deliver the parcel one by one. Okay. So let's say there is one parcel from city 0 and going to city 1, and there is another parcel from city 0 and going to city 3. So you cannot take both the parcels from city 0, drop one at city 1 and drop another at city 3. Okay, that's not the case. Basically, you first start from 0 and deliver the parcel to the first city, then again start from 0th and deliver the parcel to the third city. So first of all, you reach to the source city of 0th parcel, make it reach to the destination, then come back to the source city of parcel 1, reach it to the destination of parcel number 1. Okay, so coming back from that is not counted. Basically, moving from source of I to destination of I is counted. Okay, for all the parcels, and that we have to do individually. Okay, so now understand one thing. So there will be some ages which will be repeated multiple number of times. Okay, so let me give you a very simple example. Okay, or let's take the example from this only. What are the questions? 1 to 0 and 2 to 4. Okay, so we have to go from 1 to 0 and from 2 to 4. Okay, so first I'll go from 1 to 0. Okay, so I'll go from 1 to 0. So this would be my path, right? Then another is 2 to 4. So 2 to 4, this would be my path, right? So understand one thing. This age is never used, right? This age is used one time. This age is used two times. This age is used one time. So since this age is never used, I will associate the highest cost path with this age. What are the cost paths? 1, 2, 3, and 4. 0 is not a cost path. 0 basically denotes there is no parent of 0, right? So what is the highest cost? Highest cost is 4. So I will associate it with this age because this is never used. This age is used two times, so I will associate the minimum cost with it. So I will associate it 1 with it. Okay, so 1 and 4 are used. These two ages are used once. Okay, so I will associate the other two cost with them. So I will associate 2 and 3 with them, right? So this age is used once, so it will contribute 3. This age is used once, it will contribute 3. This age is used twice, it will contribute 2. So the total now cost would be 7. Is this much clear? If we look at all the paths, then some age will be repeated multiple times, and some age will be coming one time, some age will be coming two times, some age will be coming three times, some age will never be used. So in order to get the least cost possible, I will associate the minimum cost with the age which is coming most number of times. Is this much clear? Please let me know, then we'll move further. Okay, we will go step by step. Okay, there is one plus. 2 3 more people, please write plus or okay, clear, something. Yes. So the age which repeats the maximum time, give it the least available cost. Yes, that is the idea. Because we want the minimum total cost. So which age is repeated most number of times, if we associate the least cost with it, the total cost will be reduced. Okay. Okay. So now let's move further. Okay. Sorry. So now if I somehow calculate how many times one age is coming, okay, if I calculate how many times one age is coming, make an array of it. There are n minus 1 ages. Okay, if I make an array of count of how many times each array is coming, then I will sort it in ascending or descending order. Suppose I sort it in ascending order. I have weights of ages which also have n minus 1 elements, because total there are n elements. But the first element represents the cost of the age between 0 and its parent, which does not exist. So total there are n minus 1 weights associated with n minus 1 weights ages. So what I'll do, I'll sort this in descending order. Okay, or I can sort this in descending order and this in ascending order, and then I can say my answer is equals to answer plus count of ith age, how many times it is repeating, multiplied by the weight associated with the ith age. So this is sorted in ascending order, so the least occurring age, this is sorted in descending order, will get the maximum weight, and I will take the summation from I equals to 1 to n minus 1, right? Because there are total n minus 1 ages, then my work will be done, right? So now I need to count how many times each age is occurring in all the traversal from source to edge. Okay. Okay. Now understand one thing. We are given a tree structure. Okay. Since we are given a tree structure, there will be a single path which is minimum cost path, single minimum cost path from source to a destination. Okay. So let's say this is my source, this is my destination, then my path would be this, this and this, right? Now I can also go from year to year to year to year to year, then come back, then come back, and then come here, but that is not the minimum cost path. Okay, so there is one path from source to destination in which no node or edge will be repeated, right? So there is only a single path. Is this clear? Right? So now how can I find? See, now this question is little bit, we are moving on to the implementation part, because this is the concept part. There is nothing more to explain it, but there is some implementation logic, that how we will implement it efficiently, right? So now understand one thing. What we can do is, see, I want the count of each age, how many times it is repeated. Okay, so let me take a bigger example. Or let's take this example only. Okay, 0 1 2 3 4. Okay, this is 0, this is 1, this is 2, this is 3, this is 4. Okay, and source and destination are 1 0 and 2 4. Okay, so source and destination are 1 0 and 2 4. Okay, so 1 is the source, 0 is the destination, 2 is the source, 4 is the destination. Okay, don't confuse it with the input. Okay, input is given like this: 1 0 1 2 0 4, because this is the source array and this is the destination array. Okay, I am not writing it in that way, I am just telling 1 is the source, 0 is the destination. Okay, so what I can do is, see, 1 is the source, 0 is the destination. So now understand one thing, there is a term called least common ancestor. What does least common ancestor in a tree mean? If there are two nodes given to us, least common ancestor of those two nodes is the first parent node which is common for both. Not the direct parent, but the first ancestor node which is common to both. Okay, so let me draw a tree. Okay, so let's talk about this node and this node. So what will be the least common ancestor for this and this? It will be this node, because this is also a parent of this node and also a parent of this node, or ancestor, not parent, right? This is also a parent of both the nodes, but that is not the first one, right? So this is least common ancestor for this node and this node. Okay, similarly, if I talk about this node and this node, then this is the least common ancestor for 1 and 2, because that's the first common parent or first common ancestor between both of them. Is, please explain one more time. Oh, okay, actually we are in the middle of somewhere and other people will lose the track. So what part you didn't understand, can you tell? So I'll repeat that if you have doubt in any part. Or you joined a bit later and missed that part, is that the case? Hello, please let me know if you have doubt in a particular topic. I'll explain. If you have missed it, I would suggest you may watch it again. You will definitely get it. I have explained step by step, because if I'll start again from the beginning, the other people will lose track from here, and I've explained it part by part slowly, so you will understand it. Okay, so I hope the concept of least common ancestor is clear. Please let me know in the chat box. Okay, so now least common ancestor is clear. Okay, now understand one thing. So what I can do is, see, I want the count of each age, how many times it is repeated, right? So what I can do is, I can give one array. Okay, let me call it prefix. Okay, why I am calling it prefix, you will understand it in a time, but let's call it prefix and assign value 0 to all the nodes. Okay, okay, now let's say there in one parcel you are moving from this node and going till this node. Okay, so what I will do, I will do prefix plus 1 year and minus 2 in its ancestor. Similarly, let's say another parcel is from to its least common ancestor. Another parcel is from this node to this node. Okay, so I'll do plus 1 year, I'll do plus 1 year and minus 2 in its least common ancestor. This will be the least common ancestor for this and this, for this and this. This is the least common ancestor. So it had value plus 1, so it became minus 1, right? These were the two parcels. So what my graph became now, if I look at the graph, it became minus 2, 1, minus 1, 1, and 1. Okay. Now, if I add up the values from children to parent, okay, so basically I will get a prefix from 0th node to a particular node. Are you getting my point? So I'll take a sum up from children to parent. Okay, so this is 0. Now 0 plus 1, this will become 1. This is 0, this is 0, 0, 0 and 1, this will remain 1. Now 1 and 1, here this is 1, this is 1, so 1 plus 1 2, 2 plus minus 1, it will become plus 1. Now 1 plus 1 is 2, 2 and minus 2, this will become 0. So what is the graph which I got? If I draw it here, the graph I have got is 0 0 1 0 1 1 1 and 1. Okay, or did we did any mistake? No, I don't think we did any mistake. Okay, so basically what this is showing, see, our first parcel was going from year till year. Okay, and our second parcel was from year to year. Okay, so this age was coming one time, 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 and this age was coming one time. Okay, so this was 0 and this was 1. Okay, you can see this was 1 and this was 0, we did that mistake. Okay, so this is 0 because the parcel is going from year to year. So can you see this age? Understand one thing, let me take black marker. This age which is between this node and its parent is coming one time, and the count associated with this node is 1. How are you assigning numbers to node? Okay, I'll repeat that part. First let me complete it once. So this age is coming once, the 1 is associated with it. This age is coming 1, 1 is associated with this node. This age is coming once, 1 is associated with this node. This age is coming once, 1 is associated with this node. This age is coming once, 1 is associated with this node. This age is coming 0 times, so 0 is associated with that node. Okay, so now understand one thing. How was this age represented? Using W of I, where it was nothing but the path between ith node and parent of ith node, right? So prefix of I tells me how many times W of I will be counted. Other people, is it clear? I'll again explain it one more time, but those who were there, is it clear? Please write. Okay, just one thing, is the concept of LCA, least common ancestor, clear? Okay, so now let me explain this once more. Okay, see, let me take this node number 1, node number 2, node number 3, node number 4, node number 5, node number 6, node number 7, node number 8. Okay, so I have an array prefix for node numbers. Here I have taken from 1 to 8. Okay, 1 2 3 4 5 6 7 and 8. So initially all of them are 0. Okay, now let's take two parcels. Okay, or let's take three parcels. Okay, let's take three parcels. So prefix tells how many times the road towards the parent will be to be traveled to deliver all the presents. Yes, prefix of I tells you how many times the ith age is coming to deliver all the parcels. Okay, so let's understand here. Okay, so give me details for three parcels, source and destination. Hurry up, please give me, such that their LCA is different every time. Okay, tell me in that way, and also some age is repeating. Come on, someone. Hurry up, please, someone. 4 to 7, 2 to 8, and 5 to 1. 4 to 7, 2 to 8, and 5 to 1. Okay, thank you. So 4 to 7, 1 is the least common ancestor for them. 2 to 8, again 1 is the least common ancestor for them. 5 to 1, again all of them have the same least common ancestor. Tell me something different. Let's take this 7 to 8. Okay, 7 to 8, and 4 to 7 least common ancestor is 1. 7 to 8 least common ancestor is 3, and 5 to let's take 6 least common ancestor is 1. Okay, is that okay? Because I wanted least common ancestor to be different, so that I explained it properly. Okay, so what I am telling is, see, my first source is 4, destination is 7. So I'll say +1 in source, +1 in destination, and -2 in least common ancestor. So I'll do -2 in least common ancestor. Why I am doing so? So here +1 will come, here +1 will come, and here -2 will come. So when I'll sum up the children's, okay, so this +1 effect will also reflect here later on. So how will it help me? It will also reflect here. So basically this +1 will represent that this age is a part of path from 4 to 7. This +1 will represent that this age is a part of path from 4 to 7. Are you getting my point? So we do +1 in the source, +1 in the destination, and -2 in least common ancestor. Then when we will sum up, we will get the answer. Okay, so let's do it. You'll have a better clear idea. So let me clear this, let me clear this, and let me clear this. Okay, so now second is 7 to 8, and its least common ancestor is 3. So I'll do +1 in 7, +1 in 8, and -2 in least common ancestor. So understand one thing, I'll do +1 here, +1 here, and -2 here. So when we will take up the sum, this +1 will reflect here, this +1 will reflect here, this +1 will also reflect here, but this +1 contributed by 8, this +1 contributed by 7 will be nullified by -2. So it will not move further on. So what it basically trying to say is that this age is a part of the path from 7 to 8, or from 8 to 7. This age is a part of path from 7 to 8. This age will be a part of path from 7 to 8. But above that, the ages are not a part of path from 7 to 8. So this will be +1, this will be +1, this will be -2. So when we will sum up the values, that -2 will nullify +1 of 7 and +1 of 8. So after least common ancestor, the ages which are above it will not be a part of the path. Is that clear? Okay, so we did this. Now 5, 6, and least common ancestor is 1. So +1 in 5, +1 in 6, and -2 in least common ancestor. So it became -4, 0, -2, +1, +1, +1, +2, and +1, right? So if I write the final values on the graph, it would be uh, let me write the final values. This is -4, this is 0, this is -2, this is +1, this is +1, this is +1, this is +2, and this is also +1. Now starting from the children node, we will sum up the values. So this +1 and this +1 will become +2, this +2 and this +2 and -2. What will be the sum of all the, like, you take the sub children's value and sum it up. So here +2 and +2 is 4, 4 -2 is +2. So this will become +2. This is +1, this is +1, this is 0. So this will become +2. This is +2, this is +2, this is -4. So this will become 0. Is this much clear? So what it basically denotes is that, see, here there is +1. It means this age, which is from 4 to its parent, is occurring one time in my path. If I draw a path for the graph, see, you will understand it here. This is 1, this is 2, this is 3. Okay, this is 4, this is 5, this is 6, this is 7, and this is 8. Okay, so let me draw. First is 4 to 7, so this would be my path from 4 to 7. The other is 7 to 8. This would be my path from 7 to 8. The third is 5 to 6. So 5 to 6, this would be my path. Okay, now look here, this edge is coming how many time? One time, that's why it is plus 1. This edge is coming how many time? One time, that's why this is plus 1. This edge between 6 and 8 is coming one time, there is only green color, so there is plus 1. This edge between 6 and 3 is coming two times, one is green color, one is violet type color. Okay, so that's why this is plus 2. This edge between 7 and 3 is coming two times, green and light blue, so that's why it is plus 2. This edge between 3 and 1 is coming two times, violet and light blue, that's why it is plus 2. This edge between 1 and 2 is coming two times, blue and violet, that's why it is plus 2. And there is no edge from 1 and its parent, that's why this is 0. Now is everything clear? What does this prefix finally give us? It gives us how many times the ith edge is coming. Please write yes in the comments if you have understood. Hurry up, people, please. Two, three people, one or two more. Okay, just one. Okay, okay. So let's move further. So we understood that we can create an prefix array in which minus 2 also means it has come twice in the path. Yes, definitely. So basically, 7 and 8, if I do plus 7 here, plus 1 in 7, it means I am considering this path from root to 7. Then plus 1 in 8 means I am considering this path from root to 8. And minus 2 in LCS means this edge is considered two times, but it is not required. This is counted one time and this is counted one time. Okay, that's why also it is called prefix array, because it is basically counting of a basically we are counting the prefix sum from the root node to a particular ith node. Okay, basically it's a prefix sum only. At the end we are doing prefix, but calculating prefix in array requires a for loop. Here we need to do a dfs, which we will see, and take the sum of the children and take it up. Right, okay, got it. Okay, so now see, one is we will calculate prefix, which will denote us, which will have n values, which will denote us how many times ith edge is occurring. We have a w array which gives us the weight of the ith edge. So I can ignore the zeroth element, because 0, and there is no path from 0 to its parent because there is no parent of 0. And w of 0 is also 0 because there is no edge from 0 to its parent, so its weight is assumed to be 0. So in the prefix array, I can consider the elements from 1 to n minus 1. And in W array, I can consider the elements from 1 to n minus 1. I can sort this array prefix in ascending order. I can sort this array weight in descending order. Right? So this will basically give me the details about the n minus 1 edges, that how many times a particular edge is repeating in ascending order. This will give me the weights of n minus 1 edges in descending order. Then I can basically do summation I equals to 1 to n minus 1 prefix of I multiplied by weight of I, because I can assign any weight to any edge. So prefix of I will give me how many times ith edge has been coming while delivering the parcels, and wi is the weight of the ith edge. So basically that edge will come prefix of I times. So the total cost contribution of that edge will be prefix of I multiplied by w of I. One we will sort in ascending order, one in descending order, and we will take the sum, and this will give us the answer. Is this much clear? Okay. I was doing it for every source, destination, pair, and marking it. No, it will take a lot of time. It will take n cross m times, because if you count for each individual path, like n is the DFS amount time and m are the number of parcels, so you need to call m number of DFS, so n into m will give you. Is this much clear? Now the question arises of implementation, how we will implement it efficiently, right? So here comes the concept of finding least common ancestor in log n time, log n base 2 time. This is a different concept. Okay, so we will be first looking at this. Okay, so first of all, I think let us also side by side go with the implementation, because what will happen is we will break it into multiple parts. Okay, so it will be more clearer. Binary lifting, yes. So understand one thing, this is my solution. Okay, so I have taken LGS log n mode 2, because if n are the number of nodes, then the maximum level can be log n base 2, and just to be safe, on a safer side, I have taken plus 2. Okay, G is my adjacency list. Level of I will store the level of the ith node. This is my prefix array. And don't look at this parent array at now. Okay. So first of all, what I have done is I have made a for loop from I equals to 1 to n, and in adjacency list of I have pushed p of I, because there is a age between ith node and parent of ith node, and I have also pushed parent of I and I. Basically, I am forming the adjacency list. Okay. Yes, this is a good question. Okay, is this much clear? I have formed the adjacency list. That is what I have done, nothing else. Now, understand one thing. What I can do is, I want to find the least common ancestor for every pair of source and destination in an efficient time. Okay. So, first of all, tell me, what I will do is, I will only calculate the parent which are at the ancestors which are at a level 2 key power x type. So which are at a level 2 key power 0, 2 key power 1, 2 key power 2, 2 key power 3, 2 key power 4, and so on up till 2 key power 18. Why? Because here there are at max 10 key power 5 nodes. N is less than equal to 10 key power 5. So there cannot be more than 2 key power 18 level parents. Why? Because let's say your graph is skewed on one side. Okay, let's say n is 10, and your graph is this 3, 4, 5, 6, 7, 8, 9, and 10. This is your graph. It is a straight line. Okay, so this is the maximum level possible. Here the level of the last node is how much? 9, right? So if my n is 10 key power 5, it basically is less than 2 key power 19. Okay, you can check in the powers table. Okay, now I will only store for ith node, I will store what is the parent of ith node at 2 key power 0, what is the parent of ith node at 2 key power 1, what is the parent of ith node at 2 key power 2, what is the parent of ith node at 2 key power 3, and so on up till 2 key power 18. Now why I am doing so? Understand one thing. One way of calculating least common ancestor is to just keep moving upwards. Okay, so let's say I want to find the least common ancestor of this and this. Okay, so I keep moving upwards until I find a common node. Okay, so I go here, I go here, I go here, and find a common node. This is least common ancestor, right? But here this node was at level 3 and it required 3 steps to go up. If I store only the nodes which are at a 2 key power something level, I can take larger steps, right? So let's say I am at level 1000. Okay, or let's say I'm level 500. I can directly go to a parent which is at the which is at 256 steps above. Okay, this is 2 key power x type number, right? So my idea is, I want to find least common ancestor in minimum time. Okay, this will give in n big O of n time. Suppose I want to find least common ancestor between this node and this node. So I need to go this step, this step, this step, this step, this step, this step, and this step. It is almost big O of n, right? Sorry. So in order to make it efficient, what I'm trying to do is, for every node, I'll store its ancestor value, which is at a level 2 key power 0, which is at a level 2 key power 1, which is at a level 2 key power 2, which is at a level 2 key power 3, and so on, which is at a level, or which is at like level above, okay, which is 2 key power 18th parent. Are you getting my point? So how can we do that? So can we can use dynamic programming. How? I can take a 2D array parent of n and 19, okay, where basically parent of ij will denote the parent of I, or the ancestor of I, which is at a distance 2 key power j. Are you getting my point? See, I am only storing the ancestors which are at a distance 2 key power 0, 2 key power 1, 2 key power 2, and so on, so that I can take bigger jumps. Okay? If I am storing only this, then instead of storing that the parent is at a distance, let's say it is 2 key power 4, then instead of storing that my parent is at a distance 16, I can say that my parent is at 2 key power 4. 2 is common in all of them, so I can only store 4. 2 key power 0, 2 key power 1, 2 key power 2, 2 key power 3. 2 is common, so I can store 0, 1, 2, 3. So parent ij will denote the parent of ith node, which is at a distance 2 key power j. Okay. So can I say parent of ij is equals to parent of j minus 1. Now we need to fill this. Okay. So understand one thing. What does it say? Parent of ith node at a distance 2 key power j is equals to parent of some node at a distance 2 key power j minus 1. Now if this distance, this is the parent which I want to find. Okay. This is the ith node. The distance between this node and this parent which I want to find is at a distance 2 key power j. So 2 key power j would be somewhere in between, exactly in between. So this is the node which is at 2 key power j minus 1 distance, okay, from P. Are you getting my point? Let's me call me K. So the parent of ith node at a distance 2 key power j is equals to parent of kth node at distance 2 key power j minus 1. Is this relation clear? First tell me. All of you people who are there in the meet, you will understand it. Okay, just be patient for some time. If you have doubt, ask me again. Don't leave, I would suggest. Is this relation clear? What is k? K is this node which is at a distance 2 key power j from P, 2 key power j minus 1 from P. So basically this is P, this is I, the distance between them is 2 key power j. K is the node which is at a distance 2 key power j minus 1 from P. So parent of I, which is at a distance 2 key power j, that is P, is equals to parent of K, which is at a distance 2 key power j minus 1, which is also P. Is this clear? Okay, is K clear? Will this really speed up things, since we need to propagate the prefix one level at a time? We will require only one DFS. Okay. Someone is saying please provide code in C++. Yes, I will provide it. Just let's finish this explanation. I'll share the link. K is clear. Jashwant, is K clear? Okay. And account, haha. So is the DFS concept clear? We will require only one DFS, right? We will do a DFS, and during backtracking we will add the prefix values. Okay. We will see the code for that. It will become clear. Now we do not know K. Okay. So how will we get K? I want K in terms of I. Okay. So understand one thing. K is a distance 2 की power j minus 1 from P. P is a distance 2 की power j from K. It means the distance between K and I will also be 2 की power j minus 1. Right? So can I say K is nothing but the parent of I, which is at a distance 2 की power j minus 1. Right? So I can write this equation as parent, this at distance 2 की power j minus 1, it represents by j minus 1, and parent of I at a distance 2 की power j minus 1. Is this equation clear? Parent of I at a distance 2 की power j minus 1 is nothing but the parent of K, which at a distance 2 की power j minus 1. Sorry, parent of I at a distance 2 की power j, it is equal to parent of K at a distance 2 की power j minus 1. So K is in between I and P. So K is a parent of I at a distance 2 की power j minus 1. Is this equation clear? Okay. So using dynamic programming, we will fill up a table. We will fill up the table of parent n and 19, because 19 basically represents the maximum it can go is 2 की power 18, because 2 की power 19 is 10 की power 5, and we will have at max 10 की power 5 nodes. Okay, so let's look at the computation of this parent nodes. So basically I have called pre-compute n. So pre-compute me the parents. Okay, so it calls pre-compute function. Okay, but before that it calls a DFS function. Now why I am calling a DFS function? Because I need also the levels. Okay, so in the first DFS what they are doing is, see, what is the level of 0? 0. And I want to store their level of other nodes, so they are doing also pre-computation of levels. So I have called a pre-compute function. First I will call DFS. So this is the first DFS from line 19 to 25. So first of all it says parent of, so here I have taken array 19, and the second is the node number. Okay, first is the level number. So the direct parent, what does 0 represent? Parent which is at a distance 2 की power 0. So the direct parent of the kth node is nothing but parent, right? And I have called DFS starting from 0, and since there is no direct parent of 0, I have called it minus 1. Okay, so direct parent of kth node is parent, which is passed as a parameter. Okay, here you can also access it from the given array, this array vector p. Okay, so direct parent of ith node will be p of I. Okay, then for all the elements which are in the adjacency list of k node, if it is not equal to parent, then level of it, that is the child of k, is equals to level of k plus 1, and I have called the DFS on IT. So I have further called the DFS, and for IT the parent would be K, which is the current node. Okay, so it will call a recursive DFS, store the level of all the nodes. I have initialized level of 0 as 0, and it will assign the initial parents. So this parent at a distance 2 की power 0, that is 1, will be stored. Okay, and then so in the DFS we will compute the parent at 2 की power 0, and we will compute what level. Then I is equal to 1 and less than LG. So LG is the maximum level possible. Okay, and for all the nodes from 1 to less than equal to n, if parent of j at a distance 2 की power I minus 1 is not equal to 0, then only we are calculating it. So understand one thing. So what I have done is, by default I have said parent of ji is equals to 0. So parent of ith node at a distance 2 की power j is 0 by default, because 0 is the parent node. Okay, now understand one thing. This is my graph. Okay, so the maximum level is 3, but for this node there is no parent at a level like 2 key power 1 at a level 2, because it has only one parent. Okay, so for this, let's say it is kth node, I have said parent of k at two levels, at 2 key power 1 or 2 key power 2, is 0. Okay, so its direct parent is 0, and above that also I have said it is 0 by default. Okay, so if parent of j at a distance I 2 key power I minus 1 is not 0, that is in the if condition, then parent of ij is equals to parent of j at level 2 key power I is equals to parent of j at 2 key power I minus 1 and its parent at 2 key power I minus 1. Are you getting my point? So parent of j at distance 2 key power I minus 1 is this, and its parent at distance 2 key power I minus 1 will be the parent of j at a distance 2 key power I. So is the pre-computation function clear? Let me know. Please let me know. Then we'll move further. Everyone, please let me know. Okay, yes. Other three more people. Shyam, Jashwant, are you people there? Is this clear? Okay. Okay, so in this way we have calculated the parents. Okay, now what we will do, we will move over all the queries for I equals to 0 to m minus 1. Okay, so let's say u is one of the node, so u is the source node, source of I. V is the destination node. Okay, destination node. So now I want to find the least common ancestor. Okay, so what I will do is, first of all I will bring them to the same level. Okay, so why? Because then making them jump by equal levels will be easy. Are you getting my point? So if the level of, let's say, u is 3 and the level of v is 5, so first of all I will make this equal to 3. Okay, so how can I do that? So because if, see, understand one thing, there can be two cases. Suppose this is my let's say this is my source and this is my destination, right? Another case can be this is my source and this is my destination, right? So the level of destination here is how much? 4. Here the level of destination is how much? 4. Or it's how much? 3. Okay, this is 3. Okay, let me take this as destination. The level of this is also 3, and the level of this source is how much? 5. So if I make both the jump, if I make source and destination both jump equally, then understand one thing. Suppose I made both of them jump one step, so destination will come here and source will come here, but my LCA was this only, because it was the ancestor of source, right? So first we will make the levels of both of them equal. So if I take this source and make it to level 3, so I will push it to here. Okay, I will push it here. So I'll come to know that okay, this is only source and destination. Now I do not need to go further. But in the case where this is source and this is destination, I will push this source, or this is destination, I will push this source 2 levels up. Okay, so it will come here, but this is not equal to this. So now both of them are at level 3, but I still need to move up. Okay, so first I will make their levels equal. How will I make their levels equal in minimum number of steps? Understand one thing. Suppose u is at a distance, let's say 27. Level of u is 27. Okay, so the level from the root node, and level of v is 14. Okay, so the difference in their level is how much? 13. The difference is 13. So one way is to move the node V 13 times above. That is one way, but that will take 13 steps. Why we did the pre-computation of parent of nodes at 2 key power x distance? We need to do the more efficiently. So what I can say, this difference 13 can be represented as 1101 in binary. This is 1, this is 2, this is 4 and 8. 8 plus 4 plus 1 is 13. I can represent it like this. So can I say I can make one jump of 1 size, I can make one jump of 4 size and one jump of 8 size with node number 14, right? And I have parent values which are at a distance 2 key power x type. So I will have a parent value which is at a distance 1. I will have a value which is of the parent which is at a distance 4, and I will have a value of the parent which is at a distance 8, right? So suppose from V I moved at a distance 2 key power 0, which is nothing but 1 above. So I got V1. Now from V1 I can move 4 steps above and I get V2. From V2 I will move 8 steps above and I will get V3. Now V3, oh sorry, we will have to move U above, okay, not V. Why? Because U is at a level 27 from the root node. So from root, U is somewhere here at a level 27 and V is somewhere here at a level 14, okay. So I need this to jump for 13 steps, okay. So I'll make one jump of 1 step, another jump of 4 steps and another jump of 8 steps. Why? Because the difference in the level is 13. In binary it can be represented as like this. I have the parent value at a distance 1, I have a parent value at distance 4, and I have a parent distance value at a distance 8. So from U I'll jump one step above, I will be at U1. From U1 I will jump 4 steps above, I will be at U2. I will do this in one step only, right? So if I want to go from U1 to U2, I can say U2 is nothing but parent of U1 and 2. What does this 2 represent? At a distance 2 key power 2, which is 4. So I'll directly get U2. Then I'll jump 8 steps above and I'll get U3. U3 will be equal to parent of U2 at a distance 2 key power 3, which is nothing but 8. So in 3 steps I reach 13 steps above. Now U and V both are at level 14 from the root node. Tell me, is this clear? First, making both of them to the same level, is this clear? Someone please tell me, is this clear? Okay. So now let's look at that code. Okay. Sorry. So let's look at that code. So what I have done is, see, we have seen the pre-compute function, right? Now for I equals to 0 to m, for all the parcels which we have to reach, U is the source and V is the destination. So I am storing LC, that is the LCA, by calling the least common ancestor function and passing U and V. If I look at the LCA function, first of all, if level of U is less than level of V, swap it. So by default, level of U is more than level of V. In that way, we are proceeding. Okay. So I'll calculate difference is equals to level of U minus level of V. Okay. Then for I equals to LG minus 1, LG is 19. Okay. Because there cannot be more, the distance cannot be more than 2 key power 18. Okay. Because the number of nodes is 10 key power 5. So I equals to LG minus 1 until 0 if 2 key power I and difference. In the difference, if the bit at ith position, which is the value 2 key power I is set, it means I need to do that jump. If the difference was 13, then 3 bits were set. One, the value which the bit which is value 4 and the bit which is value 8, right? So whenever a bit is set, I need to do that much amount of jump. So if 2 key power I and difference, if ith bit is set in difference, then this if condition will return me greater than 0. This if condition will be executed and U will be equal to parent of I, sorry, u will be equal to parent of u which is at a distance 2 key power I. And when I will come out of this for loop at line 54, the level of both the nodes will be equal. Okay, so now first I will check if u and v are equal, then directly return u. Okay, so if they, so let's say there can be two cases now. Let's say this was my source or u, and this was my destination. So I made this jump up till here. Now the level of both of them are equal, but the nodes are also equal. So if u is equals to v, after making the levels equal, directly return them, because that is only the least common ancestor. The other case is, this is the source node, this is the destination node. Now this is at a level 2, this is at a level 4. So I got this is at a level 5, so I got it jump up till level 2. Okay, here. Okay, sorry, this is at a level 4, so I got it jump till here at level 2. Now both of them are second level, right? So now I will move them above. Okay, now how will I move them above? Now both of them have come to the same level. Okay, so I will see if 2 key power I, if the parent at a distance 2 key power I is same for both of them, I will not make that jump. So what I'm trying to say is, suppose this is my source and this is my destination, both of them are at level 4. Okay, now are their parents at level 2 key power 3 distance? Same. 2 key power 3 is 8, the level of this node and this node is 4. So the parent at 8 steps ahead will be what? The parent basically does not exist, so by default it will be 0. We talked in the implementation, right? So it will be 0 for this also and this also, so I will not make that step. Now I will go for a smaller bit, 2 key power 2, that is parent at distance 4. So the parent at distance 4 is what? This is 1, this is 2, this is 3, and this is 4. So it is 0. For this node, the parent at distance 4 is 1, 2, 3, and 4. It is also 0. So I will not make that move. Now I will go for a smaller bit, 2 key power 1, which is 2. The parent of this node at 2 key power 1 is how much? It is this one, right? So I will make that jump, right? So I'll come here, and from here I'll come here. Okay, from this destination I'll come here, and from here I'll come here. Okay, now again I can make a jump of 2 key power 1. No, I can make a jump of 2 key power 0, that is one level. So I will come here and I will come here. Now I cannot make a jump of 2 key power 0 also, because this is their parent, right? So here we will stop. So when we will stop, suppose this is LCA, then we will stop at year and year. Okay, so this is my u and this is my v. So now I will return parent at a distance 2 key power 0 of u. Okay, so I will return this. So if you see, I have tried to take the highest step, that is LG minus 1, and gone to smaller values. If parent of IU is greater than 0, and if they both are not equal, then U is equals to parent of U at a distance 2 key power I, take a step of 2 key power I upwards. V equals to parent of V at a distance 2 key power I, take that step upwards, right? And at the end, where will we stop? We will stop at just after LCA of u and v. So I can return the immediate parent of that node. So that will give me LCA. Is that clear? Please tell me. Sorry. Is it clear? Please tell me. Line 59, number if condition. Okay, so basically what he is saying is, if parent of u at a distance 2 ki power I, it means it is not equal to 0, then so basically parent of u at a distance 2 ki power I will return a value. So if it is 0, it will be considered as boolean value false. If it is greater than 0, it will be considered boolean value as 1, right? Now 0 is the uppermost node, right? So basically we are checking if parent of u at a distance 2 ki power I is not equal to parent of v at a distance 2 ki power I, then only take that jump. Okay, so let me make you explain it here. See, my target is, suppose this is the source node, this is the destination node, okay, or this is u number of node and this is v number of node. It was different before, but we have brought them to the same level. This is at level 3, this is also at level 3, okay. Now if I make it a jump of 2 ki power 2, which is nothing but 4, then there is no parent at a distance 2 ki power 2. So this is at a distance 1, this is at a distance 2, this is at a distance 3. But what I have mentioned, parent of j at a distance I is 0 if it is 0 or above it, right? So this node, this source node is at a level 3, okay. So there is no parent at a distance 4, so by default it is marked as 0, okay. So and for this also it will be 0, so I will not take that step. I will only take a step if the parent at distance 2 ki power I is not same for u and v. So now I'll see for a smaller jump. So 2 ki power 1 is 2. So if I jump 2 steps from here, this is my parent. And if I jump 2 steps from here, this is my parent. They are not equal. So I'll make a jump. So my u will come here and my v will come here. Now next step would be 2 ki power 0. That is one size jump. The one size jump is the same. It is the same. So I will not do it. So when I will come out of the loop, understand one thing, I was only making the jump if the parent was not equal. Now why I need to do it? Because I want to find the least common ancestor. Understand one thing. Suppose this is the source node and this is the destination node. If I make a jump of 2 ki power 2, that is 4, from here I will come here, and from here also I will come here, okay. This is common ancestor to both of them, but this is not least common ancestor. So I want to find the least common ancestor. I do not want to find any ancestor. So I will take only jumps which are not leading to the same parent. Now this is the same, but we do not know whether it is least common ancestor or not. It can be a common ancestor and not a least common ancestor. That's why we are only taking jumps which do not lead to the same parent. So where we will end, understand one thing, if this is the least common ancestor, there is some graph above it, there is one node here, one node here, there is some graph below it, there is some graph below it, we will finally end here, u and v. This we will end here. Further we will not take jump, because if we take a jump of 2 ki power 0 also, we will lead to the same parent. And to avoid finding the ancestors which are not least common ancestors, we take jumps which are as small as possible and which do not lead to the same parent. So we will end here at this position. Now I can directly say parent of u at a distance 2 ki power 0 is my LCA. So that's why if the parent of u at a distance 2 ki power I is not equal to parent of v at a distance 2 ki power I, then only take the jump. So u will become parent of u at a distance 2 ki power I, and v will become parent of v at a distance 2 ki power I. And after I am coming out of the for loop, I will return the immediate parent of node u, okay, which will be my LCA. Now is this clear? Sorry to interrupt. Thank you for your tip. Change is happening. Okay, you are welcome. Okay, Monty also got it. What is LG and how it will work if the tree is extremely unbalanced? Example, each node has only one left child. then also it will work because we are taking jumps of size 2 key power k. So if my nodes are 10 key power 5 at max, I will not be required, the largest jump will be of 2 key power 18. Okay, so I need to store only 18 parents for a particular node. Got it, Bhaiya. Thank you for so much for going in so much depth. Okay, welcome. Yes, I also. Okay, so this will work even if it is a skewed tree. Okay, so I computed list common ancestors using LC. Then, as we talked before, prefix of u plus plus, prefix of v plus plus, and prefix of list common ancestor minus 2. Then I will call another DFS which will sum up the values. So 0 is the current node and its parent is minus 1. Okay, let's see the DFS2. So this is DFS2. Currently we are at node K and this is the parent node. So I will traverse all the nodes in the adjacency list of the kth node, and if that node it is not equal to the parent node, right? Because the parent node will also be in the adjacency list. Then call DFS on it, that is the child of kth node, and now k will become the parent. So k will be a second parameter. And after coming out of the DFS during backtracking, I will say prefix of k plus is equals to prefix of it, because we want to sum up those values, right? Thank you. Okay, welcome, Shyam. Okay, someone is saying I do not know how to minimize weight. So see, let me explain it to you quickly. You can also go back and understand it. I explained step by step and in very detail. Okay, basically it is said there are, see, n minus 1 ages and n minus 1 weights associated with it. It is said that we can exchange the weights of any two ages any number of times. So basically I will count in all my m parcels from source to destination which age is repeated most number of times. The age which is repeated coming most number of times, I will assign the smallest weight to it. Okay, so that will contribute the list to my answer. Suppose there is a age which is coming 5 times, there is another age which is coming 1 time, and there are two weights, one is 1 and one is 5. So I will assign the weight 5 to the age which is coming 1 time, so it will contribute 5, and the weight of 1 to an age which is coming 5 times, so it will also contribute 5. So 5 plus 5 will be 10. But if I assign the age weight of 5 to the age which is repeated 5 times, and the age weight of 1 to the age which is repeated 1 times, it would be 26. So in order to minimize the total cost, I am assigning the least cost of age to the age which is repeated maximum number of times. Okay, no, DFS2 will be called only once. Okay, so I am passing the DFS and during backtracking I am doing the prefix sum. Is the DFS2 clear? Right, so I'll call the DFS2. Then I will sort the weight array, weight of the ages, in ascending order. And remember, I will start from first index. Why? Because the weight associated with zeroth index is just to fulfill the array, that is 0. Because there is no age between 0 and its parent, because there is no parent of 0. Okay, and I will also sort the prefix array from first position to nth position, and I will sort it in descending order. Okay, and then starting from 1 index to n minus 1 index, I will say weight of I multiplied by prefix of I. Weight is sorted in ascending order, prefix is sorted in descending order. So the age which is repeated maximum number of times, the weight associated with it will be the minimum, and so the total sum will be minimum. And finally I'll return answer. Okay, I have been following you since 2021. Okay, thank you. So we have solved this problem successfully. I hope you people have understood it. Please some comment, please write yes if you have understood it. Sorry. Hello, please write yes if you have understood this completely. Okay, okay, Shyam. Thanks where about the time I spent here. Now I will go quickly and add this prefix trick. Okay, welcome Monty. I'll have to rewatch because I don't get it. Definitely, you can rewatch it. And the last question, I have explained it step by step. After every step, I have asked, is this clear? And if there was a doubt, I have explained it. And the code also, we have not went through the code once. We have went through the code step by step. Okay, so it will be absolutely clear if you watch it again. Is it a medium or a hard level problem? I will personally assign it a hard level problem because it is DP on graph. Okay. Yes. Anything else? Okay. So there are 22 people in the stream currently. Please like the stream if you have enjoyed it, understood it. And again, I would like to say you that if you enjoyed this, uh, let me take the screen to this part. Okay. If you have if you have understood the solution, I definitely, the last question was really good and there was a lot of things to understand, and I had prepared it well, and in order to make you understand. So I would suggest, if you have understood it clearly and if you liked it really, then please do take a screenshot of the screen at present and share it on LinkedIn, sharing your experience of the teaching, and do tag me, Sandeep Jain sir, and Geeks for Geeks official account on LinkedIn, and I'll also make sure that you get reactions from the official accounts also. And please do share it on LinkedIn if you have enjoyed it and understood it really well. Okay, the third question was quite tough. I think it was DP on graph, right? Okay, thank you. I'll just wait for 30-40 more seconds if anyone wants to take the screenshot. Okay, and then we'll stop the live stream. Thank you for joining. Good night, take care. India won, that's great. Okay, guys, thank you for joining. I'll stop sharing it, and definitely, if you like the solutions, do share it on LinkedIn. Okay, thank you.